They called it primitive. For over 300 years, European science documented a plant in the mountains of South Africa, noted its honey-like properties, recorded that indigenous people had been using it medicinally for generations, and filed it away as the practice of people who didn't count, not worth commercializing, not worth studying seriously, not worth building anything around. Then the pharmaceutical industry showed up. Companies in Europe and the United States began filing patents on the bioactive compounds found inside that same plant, the compounds that the Khoisan people, one of the oldest human populations on Earth, had been extracting through traditional preparation methods for at least 30,000 years. The patents did not credit the indigenous knowledge. They did not compensate the communities. They simply took the chemistry, gave it a laboratory name, and filed the paperwork. The plant is called honeybush. This is not a story about a plant being forgotten. It is a story about knowledge being classified as worthless until someone figured out how to own it. In 2021, rooibos, honeybush's closest relative from the same biome, used by the same communities, became the subject of the first successful access and benefit-sharing agreement in the world for a plant species. The knowledge was always theirs. The system spent 300 years pretending otherwise. Honeybush is still waiting for the same recognition. Here is the full paper trail. Roost Conspiracy asks one question every week: who decided this doesn't count, and what were they protecting? We follow the patent filings, the colonial records, the legal agreements that only happened after decades of organized resistance. Subscribe now and hit the bell to understand how a plant with 30,000 years of documented use ends up as a corporate patent filing. You need to understand the specific decision that started the erasure and when it was made. The Dutch East India Company establishes a supply base at Cape Town. The VOC, the largest corporation in human history at that point, with its own army and its own legal system, arrives with one mandate: extract value from every territory it enters. The Khoisan have been in the Cape Floristic region for tens of thousands of years. They know which plants treat respiratory illness, which ones support recovery after childbirth, which ones produce sweetness that sustains energy through difficult terrain. Honeybush is central to that knowledge, a woody shrub with bright yellow flowers that smells unmistakably like honey the moment you crush a leaf. The VOC made a specific documented decision about how to categorize this knowledge. They called it primitive. Colonial law explicitly denied indigenous peoples intellectual property rights over their traditional knowledge. Everything the Khoisan knew could be observed, documented, and used without acknowledgement, without payment, without any mechanism for them to say no. European botanists documented honeybush as early as 1705. Carl Peter Thunberg, a student of Linnaeus himself, described it in detail in the 1770s. They noted the honey-like aroma. They noted the traditional uses. They wrote it all down. Then they moved on. The Dutch and later the British brought European honeybees instead. They built the sweetener infrastructure the entire region adopted for the next 3 centuries. And honeybush retreated into the mountains, still producing its compounds, still harvested by communities who never stopped knowing its value. The knowledge did not disappear. It was made legally invisible. The Khoisan are among the oldest continuous human populations on Earth. Genetic evidence places the San in southern Africa for at least 30,000 years, one of the most ancient lineages in the human family tree. For that entire span, they developed a pharmacological tradition built on direct observation of the Fynbos biome. The locations of the best honeybush stands were family knowledge passed through generations. Harvest times were observed across centuries. Preparation methods refined through thousands of years of direct experience. They used honeybush for respiratory ailments, what Western medicine would eventually classify as asthma, tuberculosis symptoms, and chronic catarrh. They brewed it for digestive support. They gave it to new mothers during recovery to support milk production and restore strength. They recognized its anti-inflammatory properties and used it for skin conditions and joint discomfort. A general wellness tonic suitable for every age group. This was not casual foraging. This was the equivalent of centuries of clinical practice. When researchers at Stellenbosch University and the Agricultural Research Council finally began serious study in the late 20th century, what they found confirmed what the Khoisan had always known. Mangiferin, hesperidin, pinitol, real, present in significant concentrations, biologically active in exactly the ways traditional use had always suggested. The science did not discover what honeybush could do. It confirmed what 30,000 years of lived observation had already documented. Then pharmaceutical companies began filing patents on those compounds. No reference to traditional knowledge, no consultation, no compensation. The legal framework, descended directly from colonial law, still did not recognize indigenous knowledge as prior art that could block a patent claim. Someone filed that paperwork. Someone decided that 30,000 years of documented human use did not constitute intellectual property while a laboratory analysis performed last Tuesday did. The answer is the same one the colonial administrators gave in 1652, just written in the language of IP law instead of the language of empire. Here is why the compounds inside honeybush were worth patenting, and why their appropriation is impossible to dismiss as a minor legal technicality. Honeybush produces its extraordinary chemistry because of where it grows. The Fynbos biome has acidic, nutrient-poor, sandy soil and dry summer conditions that destroy most cultivated plants within weeks. Plants under sustained environmental stress produce higher concentrations of secondary metabolites, the compounds they generate for protection and survival. These are the molecules that give plants their flavors, aromas, and medicinal properties. 3 compounds worth knowing by name because they are exactly what the patent filings targeted. Mangiferin is a xanthone. A 2017 study in Lipids and Health and Disease described it as a miracle bioactive compound, antioxidant, antimicrobial, anti-diabetic, anti-allergic, anti-cancer, and immunomodulatory properties. One compound doing the work most pharmaceutical companies spread across 6 separate drugs. The Khoisan identified the plant containing it through observation. The laboratory identified the compound. The patent credited the laboratory. Hesperidin is a flavonone with documented anti-inflammatory effects and potential in cancer research. Extracted by the Khoisan through traditional fermentation for thousands of years before it had a scientific name. Pinitol mimics the action of insulin, documented in the British Journal of Pharmacology. It helps cells absorb glucose without requiring additional insulin production. For 400 million people living with diabetes worldwide, that mechanism has enormous commercial value. The Khoisan used the plant containing it for metabolic support centuries before diabetes had a Western clinical definition. 1 cup of brewed honeybush, 0 caffeine, virtually 0 tannins, no added sugar, no artificial additives, sweetness, and bioactive compounds delivered simultaneously. The global honeybush tea market, $10 million. The pharmaceutical market for compounds with these properties, billions. That gap is the gap between who holds the traditional knowledge and who holds the patent. Here is what you can actually do with this plant, and why the barrier to growing and processing it is lower than almost anything else you can cultivate. The processing method refined over centuries by Khoisan communities and documented by researchers at Stellenbosch University involves very few steps. Harvest leaves, stems, and flowers during active growth. Late spring through summer when sugar concentrations peak. Cut stems back by 1/3 to 1/2. Bundle the cut material, bruise it slightly, and allow oxidative fermentation for 3 to 5 days. The material changes from green to dark brown and develops its characteristic honey aroma. Spread thin and dry in the sun for 1 to 2 days. Stores indefinitely in airtight containers. For a concentrated honey substitute, simmer dried material at 1 part plant to 4 parts water for 1 to 2 hours. Strain through fine mesh. Reduce over low heat until syrup consistency. The result is a golden liquid that behaves like honey in recipes, stores at room temperature without crystallizing, and delivers the polyphenol profile that commercial bee honey does not contain. A pot, a strainer, a heat source, nothing else. A honeybush plant costs $5 to $20 from a specialty nursery. No protective gear, no mite medications, no supplemental feeding. It thrives in poor acidic soil. Rich soil actually reduces sweet compound concentration. Most Cyclopia species tolerate temperatures down to -6 or -7 degrees Celsius. USDA zones 8 through 11 can grow it outdoors year-round. Semi-hardwood cuttings taken in late summer propagate reliably with basic rooting hormone. One plant becomes 10 within a few years. A single mature bush harvested multiple times per season for years with essentially zero input cost. Compare that to a beehive. $200 to $500 in equipment before protective gear, mite medications, supplemental feeding, or queen management. Most hobby beekeepers spend over $1,000 before their first jar. In 2025, 62% of U.S. commercial colonies collapsed in a single season. A plant the Khoisan harvested for 30,000 years requires none of that. The colonial decision to build around European bees was a choice, not an inevitability. Here is where the story gets precise, because precision is what separates investigation from conspiracy theory. The biopiracy cases involving fynbos plants are real and documented, but they are also complicated in ways that matter. The clearest documented case involves rooibos, honeybush's closest relative, same biome, same Khoisan communities. In 2019, an attempt to register a trademark over rooibos by a company with European partnerships triggered a formal legal challenge. In 2021, under the Nagoya Protocol on Access and Benefit Sharing, established in 2010 under the Convention on Biological Diversity, rooibos became the subject of the first successful ABS agreement in the world for a plant species. The San Council and Khoisan communities received a legally binding royalty. 1.5% of the FOB export value of all rooibos goes directly to those communities. The legal system took 369 years to formally agree that the knowledge was always theirs. For honeybush specifically, the South African government created the bioprospecting, access and benefit sharing regulations in 2008, requiring permission before bioprospecting South African plants and mandating benefit sharing with originating communities. Before 2008, the legal pathway for filing patents on honeybush compounds without acknowledging traditional knowledge was entirely open. What the public record does not show is a clean list of named companies that filed specific honeybush patents without attribution. The documented cases involve mangiferin and hesperidin appearing across multiple pharmaceutical patent applications. Whether specific applications cross the line into appropriation is a question being actively litigated in international IP law. What the public record shows clearly, the knowledge existed for 30,000 years. The legal framework requiring acknowledgement did not exist until 2008 nationally and 2010 internationally. In that window, the pathway for appropriation was open, legal, and used. Honeybush still produces only 400 tons per year. No benefit sharing framework comparable to rooibos exists yet. The pattern is the same. The timeline is still open. Here is what the trajectory shows, and it does not close with a clean answer because the case is not closed. In 2025, the United States recorded the worst collapse of honeybee colonies in recorded history. 62% of commercial hives gone. 1.6 million colonies vanished in 9 months. $600 million in direct losses. USDA researchers identified Varroa destructor mites resistant to amitraz, the primary pesticide used to control them. Once those mites transmit deformed wing virus and acute bee paralysis virus through a colony, the collapse becomes irreversible. You cannot stop it once it starts. Bees pollinate crops valued at over $18 billion annually in the United States alone. Globally, the figure approaches $200 billion. Apples, avocados, almonds, blueberries, cucumbers, watermelons, cranberries. The list reads like a produce aisle inventory. An industry leader asked what happens if losses continue gave one answer. I do not know that the industry can survive. The Nagoya Protocol is in force. The BABS regulations are in force. The Rooibos Agreement of 2021 proved the legal machinery exists and works. And yet the plant that 30,000 years of human observation identified as extraordinary sits at $10 million in global market value, while 80% of its supply is still unsustainably harvested from wild populations. The Khoisan communities with the deepest knowledge of how to cultivate it remain outside the commercial infrastructure. Nobody stamped this knot for publication. Nobody dissolved a committee. The knowledge is documented. The compounds are studied. The legal agreements are available. And yet the system built around its colonial replacement is collapsing in California orchards while honeybush waits at $10 million. Who is benefiting from that gap staying exactly where it is? Every week on Roost Conspiracy, we go back to the source material and ask who decided this doesn't matter and what they were protecting. Subscribe now, hit the bell, share this with one person who grows food. The archive is deep. The cases are still open. We have barely opened the first drawer.